Hello, everyone. This is the ASME Dynamic Systems Control Division podcast series. I'm host Yao Ma. In today's episode, we are very happy to have Professor Azim Eskandarian from Virginia Tech as our guest. Welcome, Azim.
Thank you, Professor Mao, if I may call you Yao. I really appreciate your invitation. It's a pleasure and honor to be invited for this podcast. And I want to send my sincerest greetings to all the audience who may be listening to this in the future.
Thank you, Azim. So many of us from the control community are already very familiar with you through your research and services over the years. But just for the sake of formality, do you mind starting with a brief self-introduction?
Sure, thank you. I start with my current position, which I'm currently the Nicholas and Rebecca Deschamps Professor and Chair at Virginia Tech Mechanical Engineering Department. I also serve as the department head there since 2015. And prior to that, I was at George Washington University for 23 years. Before that, I worked for Penn State for 3 years. And prior to that, I worked as an engineer for 6 years after I received my master's degree. So to just put this in perspective, after my receiving my master's degree, I started working as an engineer. So my positions were mechanical engineer and project engineer for a couple of different companies in Washington, D.C. area. And soon I realized that I'm really more interested in R&D work and research rather than practicing engineering, which was very beneficial and very helpful to my career. But I really liked the research environment and academic environment a lot better. So I started taking courses and taking my PhD program concurrently with working, which I don't recommend to any of my students. Because it's very hard to have two jobs or two separate things in parallel. But my personal situation was such that I had to do both. And I was lucky to find a job during the research part of my dissertation as an instructor and then as an assistant professor when I graduated.
Yeah, thank you again, Azim, for joining this podcast series. So let's kickstart. So how about you share with us some of your recent research interests, the highlights you want to share?
Sure. I think maybe it would be good for me to give a little quick background of what I've done before, which kind of leads to my current research interest. Obviously, my PhD was in mechanical engineering and in robotics, and back then in neural networks for robot modeling and simulation and control. My work experience was very much into mechanics and finite element and design for mechanical engineering. And as a continuation of that, I have helped establish a couple of centers at George Washington University with other colleagues, which they were very successful research centers working on automotive safety from all aspects of crash analysis, which involved the biomechanics of injuries, the mechanics of crash and how to create vehicles safer, and also extended to collision avoidance, which I created another center that kind of dealt with that aspect of crash analysis. Now, once you get to collision avoidance and driver assistance, the continuation of that work was leading to all the precursors to the current scientific areas that contribute to automated and autonomous driving. So my more recent work is very much focused on autonomous driving, improvement of safety and performance of the vehicles for autonomous driving. Now, fundamentally, a little more delving more into detail of that, we are looking at different aspects of automation or I use interchangeably automated and autonomous because in this community, there's a debate which one is correct. So I will use both. So I'm not taking sides with either side of that equation. But for automated driving or vehicles, I think one of the major areas of contribution, in addition to controlling the vehicle, is really perception. And the benefits of automation really comes not only in the single vehicle automation, in the connectivity of the vehicles. So I work in connected and autonomous vehicles. And as a subset of that, we're focusing a lot on the cooperative perception among vehicles. So one vehicle can have sensory information and have situational awareness, and it can share with other vehicles, but not only with other vehicles, but also with infrastructure, and in the future with vulnerable road users, which could include pedestrians or bicyclists or others. So this cooperative perception poses a lot of technical difficulties, scientific challenges that need to be addressed, that we can get into detail of that, but that's the focus of the research that I'm doing with my students, which kind of leads to something that I want to share, that really today's engineering, whether it's mechanical, civil, electrical, industrial, or what have you, has no boundaries. I mean, the work that we do really is cross and interdisciplinary, and we are all using AI, we're using machine learning, we're using neural networks, we are using deep learning methods to handle these problems. And therefore, we are collaborating with other colleagues from other departments, but we ourselves are also learning a lot of those methods that are not traditionally in mechanical engineering, but now there's no boundaries in those. So that's the focus of my research with my students. And fundamentally, it's mathematical modeling, sensor processing, signal processing, and control systems.
Right. And speaking of that, you just mentioned actually the research you're doing here is actually spans several different disciplines, different from obviously traditional definitions of mechanical engineering. And on top of that, I know you're also very much involved into the service and leadership roles in different societies. I'm aware of your involvement in leadership in the ASME, IEEE, SAE, all those kind of things. To me, as a junior faculty member myself, it feels like that's a lot of investment in terms of time and effort. And I just want to learn from your successful experience that how do you manage to navigate through these different fields, and what do you think is the most beneficial reward for doing so?
Sure. Let's start by having a quick definition of why these societies are created. You know, the societies are created, any society is created by having experts and learners in that field having some common goals and common things that they want to achieve together. That's why they create a society. So the members of membership in those societies benefits two ways, not only the members, but also the society as a whole. So not only we're learning, but we're also contributing to that society. So it's a two-way street for everybody who is involved in any society. Obviously, as we are younger and more in the learning mode, we are learning and benefiting more from the society. And as you progress into your career, I think it's time to give back more to that society and provide different services for that society. Now, each one of the societies that you named, as well as many others in the engineering profession, they bring a lot to the table for both students and younger faculty, as well as experienced faculty. Whether it's establishment of relationship between academia and industry and government, whether it's providing standards, or whether just purely providing some kind of peer group that can evaluate the discoveries in our fields or among the benefits of the society. For example, the technical activities of the societies, the conferences, the journals and transactions that societies have, they all benefit the community because it provides an evaluation, a peer evaluation, a solid peer evaluation for the field that you're in, and you're contributing to that field. So you want to be contributing to an area which has proper evaluation of your contribution, as well as you helping them to do that evaluation process. So from a academic perspective or engineering perspective or research view, the societies bring a lot to the table and bring a lot of credibility to the table where it benefits the members of that society. That's why publishing, for example, in ASME journal has precedence, or IEEE journals has precedence over other unknown publishing. And that's just one aspect of it. I think from the societies that you mentioned that I participate is because of the, as I mentioned in your previous question, it relates to the interdisciplinary, cross-disciplinary nature of the work that I've done. Obviously, mechanical engineering is my basic training and profession, so ASME is the natural professional society. That's why I participated in that. And there were a lot of benefits in my career associated with that. Similarly, the Society of Automotive Engineers, or SAE, deals with automotive industry, and a lot of the work that I have done contributed to that field, but also learned from peers in that field and created connections with industry, which otherwise would have not been possible for me as a young engineer or as a younger faculty. And then finally, IEEE, as you know, is a very large, one of the largest engineering professional societies, and it does have areas in intelligent transportation systems, for which I serve as the chief editor of their journal or transaction now, and also has intelligent vehicle transactions. It has activities in various aspects of autonomy and control systems, other societies within IEEE that are very related to the research areas that I'm engaged with. So the membership in any one of these has been tremendously beneficial to me, and I encourage all younger faculty and students to engage in this membership and contribute to them. Now, one of the things that we have sensed is that there is not enough information dissemination to students about the society. So there are campuses or departments that are very active in that, and they do a great job in recruiting students for the societies. And you know, our conferences, for example, in ASME, are doing a good job in dynamic systems and controls to bringing students to the conferences and all of that. And so they see tangibly the benefit of membership in these activities or societies. But sometimes I chat with the students, especially undergraduate students that don't know much about it, and they just don't know what's the benefit to them. I mean, the abundance of information they're getting from other sources is so much that the traditional information passing of society doesn't seem to attract them very much. But once they delve in and participate, for example, in competition, in our field, in like robotics competition or automotive competition, then they have a sense of belonging to that group or to that peer group and see the benefits of what the society is doing for them and what they could do to be part of that society. So, I mean, I highly encourage everybody who is in engineer to find the proper venue for their membership. And to answer your questions about what to do, how to balance all of that, I think we, in academia, we are service oriented, and we want to give back to our community, but it's also part of our learning experience is service. So we have to manage that along with our teaching and research responsibilities. So I see that a benefit not only for self-benefit, but also for the bigger society or for our peers.
Right. And I like what you're just mentioning about the students' encouragement to involving in the societies, and which lead to my next question. I know you, in addition to leading this research program, and you're currently also serving the department head of the mechanical engineering at Virginia Tech. So I was curious to learn from your perspective, the head of the department perspective. What are your views on the students' education and particularly engagement nowadays? And can you share some practices you implemented or encouraged the faculty to adopt that you find most effective?
Sure. I think I would like to start by first saying that as a department head or leader any role in academia, the first thing that is needed is that the first requirement is for you to be selfless. In other words, as a department head, I'm not just concerned about my own teaching or my own research. I'm really concerned about the well-being of the entire population in my department, all the students that are engaged from every area of my department, and all the faculty and staff that are working with me to make a good learning experience for those students. So selflessness and being of service to others is the first element of leading a department, which could be helpful to whoever is engaged with your department. Now, in terms of helping the students, there are many things that we have done, and many other successful departments are doing the same, is by enhancing your programs and offerings, by creating new programs for students learning, and by bringing resources and to enhance the offering for the education of the students and for the research that faculty can do in your department. So I bring you some examples, for example, of each one of these. Now, in terms of, let's say, new programs, we have worked hard to bring new laboratories to our curriculum, which many of our peers, for funding reasons or lack of resources, shy away from more hands-on. But we have experienced that a winning strategy and a successful strategy for our students have been their hands-on experience. And more students are really requesting that. And more of our industry partners, including our advisory board, mentioned that our students that have hands-on experience are better engineers that they hire. So we created like 3 of the fundamental courses that traditionally did not have laboratories. We created new labs for them that many curriculum in other departments may not have lab. One of them including control systems. There was a limited lab, but now we expanded a full-blown and a credit hour associated with that, and along with a couple of others. So enhancing hands-on experience, enhancing the experiential learning opportunities for the students during internships and summer were others that helped the students. And then in terms of other aspects, for example, graduate programs, we have introduced our new online program for master's degree students, which created a huge outreach for us for reaching out to students that traditionally could not afford or could not come to campus to study or take benefit of our faculty's experiences. So we see that as a tremendous opportunity for our future. This is something we started recently. And then other things, that resources that you can bring in terms of, I've been extremely involved in endowments, fundraising, of course, with the team, with the college, with the university, to bring resources to the department, that bring resources to the faculty and the students, whether it's funding for their research, extensive investment for startup funds for new faculty that we hire, and many resources for students, from travel to conferences, to enhancing the lab experience, to improving the diversity and mentoring for students, or what have you. So both academic and fundraising and resource allocation have been part of my responsibility that I think has helped the experience of many of the mechanical engineers. In that process, the resources allowed us to engage more with societies like ASME and SAE and many other societies, including with other departments. So I think the programs that we have introduced are enriching the experience of the mechanical engineers. I bring you just a couple of other quick examples. One is we have created a new program called Commercialization, Entrepreneurship, and Leadership for Mechanical Engineers. And we have courses for that, and we have created competition for students to get involved even before they get into the capstone design competition in the final year. And it provides resources for students to be more entrepreneurial, but also think like engineers. So it's not only the formulation and the foundational things that they're learning in their courses, but they're learning a lot about real life engineering, about products, about intellectual property, and how to move on from classroom into products, into maybe startup companies, or teaming up with companies for licensing their ideas. So we are very hopeful that that program also helps the students. So things of that nature are really many things that you can do for education of the students, and for graduate students, of course, and for the professional environment and society. Lifelong learning is one of our goals. I mean, the reason we are in academia is not just teaching and generating knowledge, but also we are constantly learning ourselves. So each time I've taught a course, I learn more about that subject than I knew previously. So being a department head allows me to influence more of lives of many more engineers that are not necessarily my own students or my own field.
Right. So besides these traditional academic venues you have mentioned in previous answers, I know you have also engaged in outreach and activities through these public medias, ABC, Fox News, Discoveries previously. And so a question is that nowadays that we also, in addition to those public medias, we also have this massive social media and online platforms like the podcast we're doing here and some YouTube channels. I was wondering, what are your thoughts and suggestions on utilizing those venues to disseminate research and or promoting the engagement for our community?
Right, very, very good question, and it's very timely. First of all, for my own background, before all of this, the social media revolution happened, and the resources that are available today, the nature of my research was that it had to do with car crashes and vehicle safety, and it was very tangible, and people relate to that. To just give you a little perspective, or to our audience a little perspective about the significance of that, it wasn't just purely our professional mechanical or engineering interest that we had in it. It was really a big societal problem, or it continues to be. Just a little statistics on that is annually about 35 to 40,000 people die in car crashes or in traffic crashes. And there are millions that are injured at the same time each year. This is just United States alone. The economic cost, not to count the value of the human loss, but just the pure economic loss in terms of productivity, insurance, and loss of other resources that are caused by crashes, is about 250 billion a year. So, and then places like World Health Organization have studied the same problem worldwide, and it's persisting in many other countries, both in Europe, Asia, Africa, everywhere in the world, and some countries by far worse than our statistics. And it's the car crashes are the 8th largest disease in terms of killing people, young people from ages, I think 14 to 29. So it is really a societal problem. So we dealt with that problem, and we developed expertise in that area, from injury pattern analysis to mechanics of car safety or barriers that interact with the vehicles, or car crashes, et cetera, et cetera. So it was very visible and tangible. That's why media had a lot of interest in the work that we did. For example, I don't know if you remember when the British Princess Diana died in a car accident. I was a younger faculty, but I was interviewed by the news, national news, because of our expertise in car crashes and seatbelt use, or the lack of the use of seatbelt, whether that had a contribution to the crash, etc. So, make the long story short, the media and outreach is useful to getting the message of engineering across. You know, as engineers, we need to do more and more to demonstrate and show the society the benefits of engineering and the prestige of engineering, you know, which in many other countries in the world, engineers are, you know, from a purely prestigious perspective, or as prestigious as other fields like medicine or law that is or business that are very popular in the United States. But as engineers, we have to do more to publicize our work, because the tangible benefit of our work reaches out to the entire society. Now, the social media has a big role and it can help in promoting engineering. Now, I have to put a cautionary note in that there's a lot of useful uses or benefits of using all of these media, because so much information and knowledge is at the fingertip of the students or whoever wishes to learn. There are courses online that would never be possible 30 years ago. So those are all the benefits that the students and everybody who wants to learn, or professional engineers who want to augment their knowledge, can benefit from them, and many of them free of charge nowadays. But the only caution I have in this is that people have to be careful about misinformation also, because anybody can put information or results of a research up there, but if they're not valid, if they're not evaluated properly, if they're not processed by an evaluation committee or peers that are knowledgeable in that field, then that could lead to misinformation. So as anything else, the social media can be very beneficial in engineering, but also sometimes it could have you know, a dangerous outcome for misinformation. So if we can put that aside, I think the social media has provided such a great opportunity for life learning and for knowledge transfer that is unprecedented in the history of mankind. I always tell my students that you know, they cannot imagine how we program, you know, in Fortran with punch cards and all of that, and many of them never seen one. They have to see those in a museum. And then when there was an error, you have to rerun the whole batch and get the card out and retype it in and submit it to somewhere else to be processed or printed for you, and then get another debug process and going. Same thing with finding papers. You know, it could take us a month or two to find a paper that we needed through the library. But now students have that in their fingertip, literally at their fingertip, you know, in their smartphones. They can get more information in a few minutes or an hour that we could get in months. So the amount of information that is available I think is really a true information revolution for learning. And the media, social media, can play a major role in that, and it is beneficial. Publicizing the successful work that the students and faculty are doing is another opportunity through social media that I think we should take advantage of. But with that cautionary note that I said earlier.
Thank you, Azim, for thoughts and suggestions. And with that, we are almost time for today's episode. And I want to thank you again for joining us today. And it's really fun conversation, and we look forward to seeing more of your work in the future.
Sure. Thank you so much for inviting me. As I said, it was really an honor to be invited, and I'm delighted that we had this conversation. And I hope that whoever listens to this podcast will benefit from it.
Thank you, Azim, and audience. This is our today's episode.